According to the National Electrical Code, the responsibility for installing a power disconnect typically falls on the entity considered the owner or employer of the installation. In this case, the manufacturing company that owns the equipment is generally responsible for ensuring its installation adheres to code. However, a common practice is the delegation of this responsibility to the third-party installer. If the manufacturing company delegates this responsibility, the installer becomes accountable for installing the power disconnect in accordance with the National Electrical Code and all other relevant applicable codes. To facilitate this, the manufacturing company has a crucial role in providing the installer with all necessary information. This includes the equipment's precise electrical specifications such as voltage, amperage, and wattage, and the required type and specifications of the disconnect. The installer, in turn, must meticulously adhere to the manufacturer's instructions and the National Electrical Code guidelines during the installation process. It's also incumbent upon the manufacturing company to verify that the installer possesses the necessary qualifications to perform the installation competently and safely. This involves confirming that the installer has undergone appropriate training, possesses sufficient experience in electrical work, and holds the required licenses or certifications in the relevant field. Upon completion of the installation, the manufacturing company should conduct a thorough inspection of the work to ensure it fully complies with the National Electrical Code and aligns with the manufacturer's specifications. Furthermore, providing the installer with a certificate of completion is essential. This certificate serves as official documentation confirming that the installation was performed in accordance with all applicable codes and regulations. It is very important to clarify that the UL rating of the equipment does not automatically satisfy the need for a power disconnect. The UL rating simply signifies that the equipment has undergone testing and meets specific safety standards. It does not encompass the installation process itself or negate the requirement for a power disconnect as mandated by the National Electrical Code and other relevant codes. Now, let's delve deeper into the technical aspects, considering scenarios and best practices. Firstly, it's crucial to understand the scope of the National Electrical Code. The National Electrical Code is a comprehensive set of standards governing the safe installation of electrical wiring and equipment. Its primary goal is to protect people and property from electrical hazards. Secondly, the power disconnect is a critical safety device. It serves as a means to energize the equipment for maintenance, repair, or in emergency situations. Without a readily accessible disconnect, working on electrical equipment becomes significantly more dangerous. Thirdly, the location of the power disconnect is also vital. It should be located within sight of the equipment and readily accessible. This ensures that workers can quickly and safely disconnect power before commencing any work. Fourthly, the type of disconnect required depends on several factors, including the voltage and amperage of the equipment, the environment in which it is installed, and any specific requirements outlined in the National Electrical Code. Common types include fused disconnects, non-fused disconnects, and circuit breakers. Fifthly, the manufacturing company's responsibility extends beyond simply providing the equipment. They must also provide clear and concise instructions regarding the installation and operation of the equipment, including the proper selection and installation of the power disconnect. Sixthly, the installer's responsibility includes not only installing the disconnect correctly but also ensuring that it is properly labeled and that the location is clearly marked. This helps to prevent confusion and ensures that anyone working on the equipment can easily locate and operate the disconnect. Seventhly, regular inspections are crucial. The manufacturing company should conduct regular inspections of the equipment and the power disconnect to ensure that they are in good working order and that they continue to meet the requirements of the National Electrical Code. Eighthly, documentation is key. All aspects of the installation, inspection, and maintenance of the equipment and the power disconnect should be thoroughly documented. This documentation serves as a valuable record and can be used to track any issues or problems that may arise. Ninthly, training is essential for both installers and maintenance personnel. They should receive comprehensive training on the proper installation, operation, and maintenance of the equipment and the power disconnect. Tenthly, staying up to date with the latest version of the National Electrical Code is crucial. The National Electrical Code is updated every 3 years, and it is important to ensure that all electrical work is performed in accordance with the latest requirements. Consider the scenario where the 110 volts alternating current unit is installed in a damp location. In this case, the National Electrical Code may require the use of a disconnect that is specifically rated for wet locations. Another scenario involves equipment that is located in a hazardous area, such as a paint booth. In this case, the disconnect must be explosion-proof and comply with the requirements of Article 500 of the National Electrical Code. The control voltage being 12 or 24 volts direct current does not alleviate the need for a disconnect on the 110 volts alternating current side. The direct current control voltage circuits may also require overcurrent protection and disconnecting means, but these are separate from the requirements for the 110 volts alternating current power supply. Let's further examine specific sections of the National Electrical Code that are relevant to power disconnects. Article 430.102 addresses the location of disconnecting means for motors and motor controllers. It requires that the disconnecting means be located within sight from the motor and the driven machinery location. Article 440.14 covers disconnecting means for air conditioning and refrigerating equipment. This section mandates that a readily accessible disconnecting means be located within sight from and readily accessible from the air conditioning or refrigerating equipment. Article 600.6 addresses disconnecting means for electric signs and outline lighting. It requires that each sign and outline lighting system have an individual disconnecting means. The type of enclosure for the disconnect is equally important. The National Electrical Code specifies different enclosure types based on the environment in which the disconnect is installed. For example, a National Electrical Manufacturers Association Type 4 enclosure is designed for use in wet locations, while the National Electrical Manufacturers Association Type 7 enclosure is designed for use in hazardous locations. Selecting the correct disconnect size is critical for safety and performance. The disconnect must be rated to handle the maximum current that the equipment is expected to draw. Using an undersized disconnect can result in overheating, equipment failure, or even a fire hazard. The National Electrical Code provides tables and formulas for calculating the required disconnect size based on the equipment's voltage, amperage, and other factors. Understanding overcurrent protection is also important. The disconnect should be protected by an overcurrent device such as a fuse or circuit breaker. The overcurrent device is designed to protect the equipment and the wiring from damage caused by excessive current. The National Electrical Code specifies the maximum allowable overcurrent protection for different types of equipment and wiring. Consider the scenario of installing a new drive-up lane system at a bank. The installation will involve both 110 volts alternating current power for the main unit and 12 or 24 volts direct current control circuits. The following steps should be taken. Firstly, review the manufacturer's specifications for the equipment. This will provide information on the equipment's electrical requirements, including the voltage, amperage, and recommended disconnect size. Secondly, consult the National Electrical Code to determine the specific requirements for power disconnects. This will include the location, type, and size of the disconnect. Thirdly, select the qualified electrician to perform the installation. The electrician should have experience with commercial electrical installations and be familiar with the National Electrical Code. Fourthly, ensure that the electrician obtains the necessary permits and inspections. This will help to ensure that the installation is performed safely and in accordance with all applicable codes. Fifthly, inspect the installation to ensure that it meets the requirements of the National Electrical Code and the manufacturer's specifications. This will include verifying that the disconnect is properly located, sized, and labeled. Sixthly, provide training to bank personnel on the operation of the equipment and the location of the power disconnect. This will help to ensure that they can safely operate the equipment and disconnect power in an emergency. Another crucial aspect is grounding and bonding. The National Electrical Code requires that all electrical equipment be properly grounded and bonded. Grounding provides a path for fault currents to flow back to the source, which helps to prevent electrical shock hazards. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, which also helps to prevent electrical shock hazards. The size of the grounding and bonding conductors must be in accordance with the National Electrical Code. Now consider the use of flexible cords and cables. The National Electrical Code restricts the use of flexible cords and cables for permanent wiring. Flexible cords and cables are generally only permitted for connecting portable equipment or for short runs where it is impractical to use rigid conduit or electrical metallic tubing. If flexible cords or cables are used, they must be properly supported and protected from physical damage. Also, consider surge protection. Electronic equipment is susceptible to damage from voltage surges caused by lightning or other electrical disturbances. Surge protection devices can help to protect the equipment from these surges. The National Electrical Code requires surge protection in certain applications, such as for sensitive electronic equipment in hospitals. The selection and installation of surge protection devices should be based on the equipment's sensitivity and the level of exposure to voltage surges. Furthermore, consider energy efficiency. When selecting electrical equipment, it is important to consider energy efficiency. Energy-efficient equipment can save money on electricity bills and reduce the environmental impact of the installation. The National Electrical Code does not mandate the use of energy-efficient equipment, but it does provide guidance on how to select and install such equipment. The National Electrical Code also addresses the use of arc fault circuit interrupters or arc fault circuit interrupter. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults. An arcing fault is a dangerous condition that can occur when electricity jumps between two conductors. Arc fault circuit interrupters are required in certain areas of the home, such as bedrooms, and may also be required in commercial installations. The use of tamper-resistant receptacles is another safety measure to consider. Tamper-resistant receptacles have shutters that prevent children from inserting objects into the receptacle slots. Tamper-resistant receptacles are required in dwelling units and in childcare facilities. Regarding the installation of electrical equipment in suspended ceilings, the National Electrical Code has specific requirements. The electrical boxes and equipment must be properly supported from the building structure. The suspended ceiling grid cannot be used as the primary support for electrical equipment. In addition to the National Electrical Code, other codes and standards may also apply to the installation of electrical equipment. These may include local building codes, state electrical codes, and industry standards. It is important to be familiar with all applicable codes and standards before commencing any electrical work. Another important consideration is the proper labeling of electrical equipment. All electrical equipment should be clearly labeled with its voltage, amperage, and other relevant information. This helps to prevent confusion and ensures that workers can safely operate the equipment. The National Electrical Code requires specific labeling for certain types of equipment, such as panel boards and disconnect. In summary, the responsibility for installing a power disconnect can be delegated from the manufacturing company to the installer, but the manufacturing company retains the ultimate responsibility for ensuring code compliance. Proper communication, documentation, qualified personnel, and adherence to the National Electrical Code are essential for a safe and compliant installation. This explanation provides a thorough overview of the responsibilities and technical considerations involved in installing power disconnects for electrical equipment, especially in the context of a manufacturing company using third-party installers.